Alright, so this is the second part of today's lesson where we do transformation, where there is a vertical stretch and compression. So if you look at both these problems, this one has a vertical stretch, this one has a vertical compression, the second one. So let's see how we will do that on the graph. As everything else, we will write our parent function, so I can see what's happening to x is getting squared. So y equals to x squared is my parent. And what are the transformations taking place? Transformations taking place are reflection over x-axis, and then vertical stretch of 2, and then 3 units. This is -3, so in the positive direction, so to the right, or you can use an arrow. And the last is 4 units up, because +4. Okay, let's go ahead and quickly draw the parent as a dotted line. This is my parent. Sorry, this is the vertex of the parent. 1 and 1, -1 and 1, and 2 and 4, -2, and also 4. So it kind of looks like this. I should remember to put it as draw. Sometimes I forget and I just draw it dark. I get so kind of engrossed in what I'm doing. I forget that this should be dotted because it's a parent and we haven't yet done transformation. Okay, now let's do the transformation. The transformation for this will be, let's first take care of the vertex. So 3 units to the right and 4 units to up. So this is where I'm looking at. This is my new vertex. And then its reflection, so it will come down. So instead of doing 1 across 1 down, 1 across 1 down, that would be it if I didn't have this 2 in the front. But the fact that I have a vertical stretch of 2, that means it's growing at twice the speed. So let's go ahead and see how you want to take care of this. So when you have x, and this is y equals to x squared, right? This is my parent. So 1 will become 1, -1 is also 1 because -1 squared. And then if I move 2, I go up 4, and then if I do -2, I do 4 again because -2 squared. But now what we need is, because the vertical stretch is 2, I need to take this y. So it's twice of this. It's going at. So basically you want to take this, the new y, which is going to be 2y, twice of it. 1 square is 1, so this you'll move actually 2 units. This is also 2 units. This is 8 units. This is 8 units. So do you see that now? The output is going to be twice of the old y. The output is going to be, so the y is going to be twice of that. Is everybody clear? Because of this 2. So basically, from my new vertex, and remember it needs to go down. So you can either put negative here itself or just remember that it goes down, either which way. So x will, so ignore this. When you move x on 1, so let's say this is 4, 5, 2, 1, okay, whatever, yeah. So when I move 1 unit x on the across, I will move 2 units. Normally I will move 2 units up, but now it's reflection, so I'll move 1, 2. So this is my second point. And then when I move 1 back, again I move 1, 2. And then when I move 2 across, 1, 2, you want to be moving 8. So from 3 you're going to 5, and you want to be 4, another 4, somewhere here it will be. And same thing. From here, yeah, you want to be moving 8, so this will be here. Everybody good? So this is my new vertex. I move 1, 2, here, it should be more like here. So this is my vertex. This is the vertex, this is the first point, this is the second point. So we're looking at this equation. So if you can see that it's narrower than the original one. It's basically moving 2. So when you do 2 from here, you go to 5 and you move down 8. When you go from 3 to 1, you move down 8. Maybe it moves down even more, maybe it's even narrower, but I don't use a graph paper, so maybe not counting properly. So basically that's what's going to happen. It's going to be narrower, and this is going to be my new table. This is going to be my new table. Okay, let's do one more and see how we do with it. Same thing. This is going to be a vertical compression. So my parent is I'm still working with the quadratic. Let's see what the transformations are. So there's no reflection. There's half vertical stretch, compression, sorry, vertical compression, and then 2 units to the left because +2, and 3 units down. And let's see how my graph is going to look like. So I'm skipping the parent just because it's the same quadratic. What we're going to do is we're just going to go straight to the transformation. So basically, take care of the vertex first. 2 units to the left, 1, 2, and 3 units down. So 3 here. So this is my new vertex. This is my new vertex. What's going to be my next point? So normally I would have said 1 across, 1 up. It would have been here, but that's not, because there's a vertical stretch. So what I do is I create the same table. So 1, -1, 2, -1. 1 square is 1, -1 square is also 1, 2 square is 4, -2 square is also 4. But that's not what I want. I want half of y. So this becomes half, this becomes half, this becomes 2, this becomes 2. So this is the point that you will take. So let's go ahead and count this. So first point, when I move 1 in the positive direction, I will go up only half. So it's moving it much smaller shape. And then when I move -1, that moving back, again I'm moving up only half. Okay. Then when I move 2, 1, 2, right? I'm moving 2. Normally I would have moved 4 up, but right now I'm moving only 2. 1, 2. So there's 1 point, this is 1 point. 1, 2, 1, 2. So it looks, so you will see that it looks much broader. So that is your new transformed graph, which has a vertical compression of half. That means it's growing at a slower pace, half the pace. That means it's broader. It's when a mountain climbs slowly, it's kind of a less steep mountain. So that's what it is. All right, we're going to stop this.